Imagine for a moment a silent signal traveling through the vast emptiness of space, a signal that defies explanation and challenges everything we think we know about the universe. These aren't the radio waves we've come to expect from distant galaxies or the predictable pulses of known celestial bodies. These are anomalies, whispers from the cosmos that seem to come from nowhere and everywhere at once. What if I told you that some of the most perplexing signals we've ever detected appear to be linked to some of the fastest objects in existence, stars moving at unimaginable speeds through the interstellar void? We're talking about hypervelocity stars, cosmic speedsters racing through our galaxy at millions of miles per hour, leaving behind trails of mystery and wonder that have astronomers scratching their heads in both confusion and excitement. These hypervelocity stars are unlike anything else we've observed. Born in violent cosmic events, sometimes ejected from the heart of our galaxy by the supermassive black hole lurking there, they travel at speeds so tremendous that they can actually escape the gravitational pull of the Milky Way itself. But here's where the story takes an even more fascinating turn. As these stellar speed demons streak across the universe, they seem to be accompanied by signals that we can't quite decipher. Signals that don't match any known natural phenomena, signals that appear and disappear without pattern, signals that hint at something extraordinary happening in the depths of space. It's as if the universe is sending us coded messages, and these hypervelocity stars are the messengers carrying them across the cosmic expanse. Today, we're embarking on a journey into this cosmic detective story, where we'll explore 25 of the most baffling, unexplained signals ever detected in connection with these incredible stellar travelers. Each signal represents a puzzle piece in a larger mystery that stretches across light years and challenges our understanding of physics, astronomy, and perhaps even the nature of reality itself. This isn't just about cataloging strange occurrences, it's about venturing into the unknown, asking questions that have no easy answers, and experiencing the thrill of discovery that has driven human curiosity since we first looked up at the night sky. So settle in, open your mind to the possibilities, and join me as we unravel the secrets behind these cosmic enigmas that continue to captivate scientists and dreamers alike. Our journey into the unknown begins not in our own galactic backyard, but in the direction of our nearest major galactic neighbor, Andromeda. It was there that astronomers first detected a signal that would set the stage for a series of cosmic mysteries. This wasn't a uniform blast of energy or a steady radio hum. Instead, it arrived in a series of rapid, intense pulses, a staccato rhythm beamed across the intergalactic void. The signal, designated HVS-1 for scientific record-keeping, exhibited frequency patterns that were immediately recognized as bizarre. Most natural cosmic signals have a certain predictability or a gradual drift in frequency, often caused by the rotation of a planet or a star. This was different. The pulses seemed to switch between two distinct frequency bands almost at random, like a radio dial being twisted back and forth by an unseen hand, creating a pattern that no known celestial phenomenon could produce. The source of this enigmatic transmission was traced back to a star, later named Icarus Prime, which was moving at a velocity that defied belief, an astounding 1,200 kilometers per second. To put that incomprehensible speed into perspective, a star moving that fast could travel the distance from Earth to the Moon in a mere 6 minutes. This placed it firmly in the category of a hypervelocity star, an object with enough kinetic energy to break free from the gravitational chains of its home galaxy. The sheer velocity of Icarus Prime points to a truly violent origin story, likely a close gravitational encounter with the supermassive black hole at the center of its own galaxy, which acted like a cosmic slingshot, hurling it out into the emptiness between galaxies. Yet the star's incredible speed is only half the mystery. The pulsed nature of the signal it seems to be broadcasting is what truly baffles scientists. Pulsars, the rapidly spinning neutron stars we know of, emit regular pulses with the precise consistency of a cosmic metronome. The signal from Icarus Prime possesses no such regularity. Its pulses are erratic, arriving in clusters of 3 or 4 rapid bursts followed by long periods of total silence. This irregular cadence rules out all conventional explanations. It doesn't match the emission profile of any known star type, nor does it align with the behavior of matter falling onto a white dwarf or a neutron star. The signal's very existence suggests we might be witnessing a completely unknown stellar process, perhaps a new type of energy conversion happening within the star's atmosphere or magnetosphere under the extreme conditions of its hypervelocity journey. One of the most compelling and speculative theories proposed to explain the Andromeda anomaly involves exotic matter. Could the tremendous forces involved in the star's ejection have triggered a transformation in its very composition? Some astrophysicists hypothesize that strange matter, a theorized state of matter composed of strange quarks, could be present within its core. The interactions between this exotic core and the star's normal outer layers could potentially generate bursts of energy in an unpredictable manner, creating the strange pulsed signal we observe. While this remains a highly speculative idea, it underscores a profound truth: this signal is forcing us to confront our understanding of physics itself might be incomplete, and that the most extreme corners of the universe could be hiding forms of matter and energy we have yet to dream of. While our first signal arrived with a staccato rhythm, the second mystery takes a completely different form, emerging as a faint, ghostly whisper from the constellation of Gemini. This signal, officially catalogued as HVS2 but nicknamed the Gemini Ghost by the astronomers who first detected it, is the very definition of persistence. Unlike the powerful, erratic pulses from Andromeda, the ghost is a continuous, low-level emission that has been detected for years, never truly fading away but instead fluctuating in a way that has defied all attempts at decoding. It doesn't pulse on and off. Instead, its strength or amplitude rises and falls in a seemingly chaotic dance that follows no discernible rhythm, pattern, or periodic cycle that our most advanced algorithms can identify. This amplitude modulation is the core of its mystery. Natural cosmic radio sources often vary in predictable ways. A pulsar's spin creates a steady, repeating pattern, and a star's rotation can cause a gradual brightening and dimming. The Gemini Ghost possesses none of this order. Its intensity changes are completely aperiodic, shifting from a barely detectable whisper to a slightly more prominent hum and back again without any warning or regularity. It's as if we're listening to a radio station where the volume knob is being turned by someone who isn't following any sheet music, creating a random, meandering signal that feels almost deliberate in its refusal to conform to any known law of physics. The hypervelocity star at the heart of this mystery, designated Gliese 44-9, presents its own set of puzzles. Spectrographic analysis of its light revealed a chemical composition that left researchers stunned. This star is unusually rich in heavy elements like gold, platinum, and uranium metals that are typically forged in the most violent stellar explosions, supernova. For a star to be catapulted across the galaxy at over 800 kilometers per second and be coated in these rare elements suggests a truly cataclysmic past. The prevailing theory is that this star was once part of a binary system, and its companion met a spectacular end in a supernova. The incredible force of that explosion would have not only seeded it with these heavy elements, but could have also provided the violent kick that sent it hurtling into the void as a hypervelocity ejector. This violent history directly feeds into the two leading theories attempting to explain the ghost's strange signal. The first theory posits the existence of an unseen companion, a dense stellar remnant like a neutron star or a black hole that survived the supernova and is still locked in a tight, eccentric orbit with Gliese 44-9. As this dark companion swings wildly around the star on its elongated path, Its powerful gravitational and magnetic fields could be constantly twisting and compressing the star's own magnetosphere. This turbulent interaction could be generating the erratic radio emission we detect, with the unpredictable orbital mechanics creating the signal's random amplitude modulation. We wouldn't see the companion itself, but its gravitational hand would be the one twisting the volume knob. The second theory looks outward into the lonely space the star is traversing. As a hypervelocity star, Gliese 44-9 is moving through the interstellar medium, the sparse soup of gas and dust between stars at an incredible speed. This isn't a gentle cruise, it's a supersonic rampage. The leading theory suggests the star's powerful magnetic field, acting like a cosmic plow, is scooping up this interstellar material and accelerating it to high energies. This process could create a fluctuating shock wave ahead of the star, a turbulent region where particles are constantly colliding and generating radio waves. The random density fluctuations in the medium itself encountering a slightly denser cloud of hydrogen here or a thinner region there would then cause the observed random variations in the signal's strength. In this scenario, the Gemini ghost isn't a message from the star itself, but the sonic boom of its journey, a cry against the silence of the space it tears through. Leaving behind the chaotic whispers of Gemini, our search for cosmic anomalies brings us to one of the most beautiful constellations in the northern sky, Cygnus the Swan. It is here that astronomers detected a signal so subtle and strange it was almost missed entirely, a phenomenon now known as the Cygnus whisper. Unlike the sharp pulses of our first signal or the erratic hum of the second, the whisper is an extremely low-frequency emission, a deep, rumbling vibration that seems to resonate through the fabric of space itself. Its most extraordinary feature isn't its power, but its structure. The signal possesses a complex harmonic signature, a fundamental frequency accompanied by multiple higher overtones, creating a chord-like quality that is almost musical in its arrangement. This intricate structure is incredibly rare in nature, as most cosmic radio sources emit a broad, noisy spectrum. The presence of these clear, distinct harmonics strongly suggests some form of precise, repeating motion is at work, like a pendulum swinging in the void or an object tracing a perfect circle over and over again. The star responsible for this cosmic melody is a true celestial runaway, designated SDSSJ 12345. By meticulously tracking its path across the sky and measuring its Doppler shift, astronomers have been able to trace its journey backward through time. The trajectory points like a perfectly straight arrow directly to the heart of our own Milky Way galaxy, the galactic center. This is a region dominated by Sagittarius A star, the supermassive black hole with a mass 4 million times that of our Sun. The fact that this star's path originates from this specific point is the single strongest piece of evidence that it was once part of a binary star system that ventured too close to the black hole's immense gravitational grasp. In a violent event known as the Hill's mechanism, one star was captured by the black hole while its companion was slingshotted outward at a phenomenal speed, ejected from the galactic core to become the hypervelocity star we observe today. It was a gravitational robbery of cosmic proportions, and this star is the lone survivor cast out on an infinite journey. Yet, the mystery of its signal only deepens when we look at its behavior over time. The Cygnus whisper does not broadcast with a constant strength. Instead, its intensity varies dramatically over timescales of decades, fading to near invisibility for years before swelling back to detectable levels. This long-term variation is what truly separates it from other variable signals and makes it so difficult to study. We are not dealing with a rapid flicker or a monthly cycle, but a change so slow it requires a human lifetime of observation to even begin to chart its pattern. This rules out simple stellar rotation or short-term orbital cycles as the sole cause. The leading hypothesis to explain both the harmonic structure and the long-term variation involves a hidden, dense companion. Imagine the hypervelocity star is not traveling alone. Theorists propose it may be locked in a very wide, slow orbit with a compact object, a white dwarf, a neutron star, or even a stellar mass black hole that was ejected alongside it from the galactic center. As this dark companion moves along its extremely elongated orbit, its intense gravity and magnetic field would periodically disrupt the primary star's outer layers or its own magnetosphere. The harmonic nature of the signal could be caused by a precise orbital resonance between the two bodies, while the decades-long fluctuations in signal strength could correspond to the companion's long orbital period, only exerting its maximum influence at the closest point of its flyby. We are essentially listening to the echo of a distant, invisible dance between a star and its ghostly partner, a duo flung from the galaxy's core and destined to waltz together through the emptiness of intergalactic space for eternity. Shifting our focus from the slow, harmonic whispers of Cygnus, we encounter a phenomenon of pure, unadulterated cosmic violence, the Orion outburst. This event was not a subtle signal or a persistent hum, but a singular, cataclysmic explosion of energy so immense that for a brief, dazzling moment, it completely overwhelmed the light of its own host star. In the vast, silent ledger of astronomical observations, the outburst stands out as a brilliant, incomprehensible exclamation point. The data revealed an energy release that was staggering, equivalent to our Sun outputting its entire energetic budget for over 100,000 years in a single, concentrated blast lasting less than 24 hours. This wasn't just a star brightening, it was a star briefly and impossibly becoming a different kind of object altogether, a transient beacon of unimaginable power flashing in the darkness of the Orion constellation. The hypervelocity star at the center of this cataclysm, a blue straggler designated TYC 5301221-1, only adds to the profound mystery. Blue stragglers are themselves unusual stars, appearing younger, hotter, and bluer than the other stars in their population, often because they have cannibalized a companion or merged with another star. This particular star was already streaking through space at over 700 kilometers per second when it suddenly decided to stage its own spectacular light show. The sheer power of the outburst immediately eliminated most mundane explanations. A simple stellar flare, even a superflare from a magnetically active star, would be a mere spark compared to this detonation. This was energy on a scale that points to a fundamental restructuring of the star itself, a catastrophic event that rearranged its very structure in a geological instant. Scientists have proposed several theories to explain such an energetic anomaly, each one more extreme than the last. The leading hypothesis involves a truly apocalyptic stellar merger. Imagine this hypervelocity star wasn't always alone on its journey. It could have been part of a triple star system, a complex gravitational dance that was stable until its immense speed and the tidal forces of interstellar space disrupted it. The theory suggests the outburst was the final, furious act of a smaller, dense companion star, like a white dwarf that had been orbiting the primary star since their ejection from the galactic center. After millions of years, their orbits decayed, and the white dwarf spiraled inward, colliding with and being completely consumed by the larger star. The incredible energy released from the friction, compression, and eventual fusion of the white dwarf's material would have been ejected in a single titanic blast, outshining the star before settling back into a new, hotter equilibrium. Another compelling theory looks inward to the star's own core. Some astrophysicists speculate that the extreme conditions of a hypervelocity journey, the constant battering by the interstellar medium and the incredible internal stresses could have triggered a delayed and violent phase transition within the star's heart. It's possible the fusion processes in the core became suddenly and drastically more efficient, a sort of thermonuclear runaway on a stellar scale. This wouldn't be a supernova where the star is destroyed, but a violent convulsion where the star's engine temporarily goes into overdrive, ejecting a shell of energy and matter before settling down again. This process, while theoretically possible, has never been observed, making the Orion outburst a potential candidate for an entirely new class of stellar behavior. The most perplexing aspect of this event, however, is its uniqueness. Despite now knowing of dozens of hypervelocity stars, we have never witnessed another outburst of this magnitude. This singularity is a major puzzle. It could mean the conditions required are exceptionally rare, a specific type of star with a specific type of companion, ejected at a specific velocity, triggering the event at the specific moment we happen to be looking. Alternatively, it could suggest these events are more common but incredibly brief, making them easy to miss in the vastness of space. Our telescopes are powerful, but they cannot watch every star in the sky continuously. The Orion outburst might not be a one-in-a-universe event, but rather a one-in-a-million-year event for any given star, and we were simply fortunate enough to have our instruments pointed in the right direction at that precise, phenomenal moment in cosmic history. If the Orion outburst was a moment of cosmic violence, the Perseus paradox presents us with a quiet, creeping mystery that defies one of the most fundamental laws of physics. Astronomers tracking the hypervelocity star designated HOP 13044 made a baffling discovery. As this star, hurtling away from us at nearly 900 kilometers per second, increased its distance, the signal it emitted, known as HVS5, did not fade. It remained unwavering, a constant, coherent radio whisper that held its strength with impossible tenacity. This directly contradicts the inverse square law, a bedrock principle of physics which states that the intensity of a signal or force radiating from a point source diminishes in proportion to the square of the distance from that source. To put it simply, a light should get dramatically dimmer the farther away you move. This signal simply did not care. Its stubborn refusal to fade transforms a simple observation into a profound paradox that challenges our core understanding of how energy and information propagate through the universe. The immediate and most tantalizing explanation for this bizarre behavior is the phenomenon of gravitational lensing. This occurs when the immense gravitational field of a massive object, like a galaxy or a black hole, acts as a cosmic magnifying glass, bending and focusing light from a more distant source. It's possible that between us and the hypervelocity star HOP 13044 lies an unseen, massive object perfectly aligned to focus the star's signal directly toward Earth. In this scenario, as the star moves farther away, the intricate gravitational lens subtly adjusts, compensating for the increased distance and keeping the apparent signal strength constant. We wouldn't be seeing the signal's true intensity, but an amplified version, held steady by the precise curvature of space-time around an invisible cosmic lens. This would require a perfect and stable alignment over many years, which is rare but not impossible. Yet, if no such lens can be found, the implications become far more extraordinary. We are forced to consider that our understanding of how signals travel through the vacuum of space might be incomplete. Perhaps under certain extreme conditions related to the hypervelocity star's immense speed or powerful magnetic field, the signal is not propagating as a simple spherical wave. It could be naturally focused into a narrow, intense beam like a stellar lighthouse, and Earth just happens to be perfectly situated in the path of that beam. Alternatively, the signal might be interacting with the interstellar medium in a completely unknown way, perhaps drawing energy from it or creating a self-reinforcing wave that maintains its coherence over incredible distances. These are highly speculative ideas, but the very fact that scientists are willing to entertain them shows just how deeply this paradox challenges established physics. The Perseus paradox does more than just present a puzzle. It forces a fundamental reassessment of our methods. This signal's constancy creates a unique problem for astronomers trying to determine the true power of the source. Without the natural dimming that comes with distance, we have no reliable way to gauge how energetic this signal truly is. It could be a relatively faint emission from the star that is being massively amplified by a lens, or it could be an impossibly powerful broadcast whose true strength is only now being revealed as its distance increases. This ambiguity makes it one of the most difficult signals to categorize and understand, a true enigma that reminds us that in the vast and strange cosmos, even the most reliable rules can have startling exceptions. Venturing closer to the very heart of our galaxy, we encounter a signal so mathematically elegant it feels almost crafted. Emerging from the turbulent region near the supermassive black hole Sagittarius A star, the signal known as the Sagittarius sequence was initially dismissed as instrumental noise. But upon closer inspection, researchers discovered its pulses were far too precise to be any known natural phenomenon. The signal, designated HVS6, is composed of a series of bursts of energy whose timing follows an unmistakable and breathtaking pattern, the Fibonacci sequence. Each pulse occurs after a number of milliseconds that corresponds to the next number in this famous progression, where each number is the sum of the two preceding it. The signal breathes in a rhythm of 1, 1, 2, 3, 5, 8, 13, and so on, creating a cadence that is intimately familiar to mathematicians and appears throughout nature in sunflower seed spirals and nautilus shells, but is utterly unprecedented in the raw, chaotic emissions of deep space. The hypervelocity star linked to this cosmic metronome is a true product of its violent birthplace. Designated S2004, this star is racing away from the galactic center at a mind-numbing velocity of 1,500 kilometers per second. This staggering speed makes it one of the fastest hypervelocity stars ever documented, a clear indicator that it received a truly phenomenal gravitational kick. Its trajectory points directly back to a close encounter with the immense gravity well of Sagittarius A star itself. The prevailing theory suggests it was once part of a binary system that strayed too close to the black hole. One star was captured, while this one was flung outward with enough energy to not only escape the galactic core but to eventually leave the galaxy entirely. It is a celestial cannonball fired from the most powerful cannon in the Milky Way. This origin story lies at the heart of the intense debate surrounding the signal. One camp of astrophysicists argues for a stunningly complex yet natural explanation. They propose that the star's unimaginable ejection event did not simply throw it into space. It also sent powerful seismic waves or stellar oscillations rippling through its interior. The unique conditions of this gravitational slingshot, combined with the star's specific composition and magnetic field, could have somehow excited a set of resonant frequencies within the star that just happened to harmonize in a Fibonacci ratio. In this view, we are witnessing an incredibly rare and beautiful example of natural physics, where the chaos of a black hole encounter gave birth to a temporary and perfect order within the star's pulsating heart. It would be a cosmic coincidence of the highest order, but not an impossible one. The other side of the debate finds the natural resonance theory too convenient, arguing that the odds of such a perfect mathematical pattern emerging from random stellar vibrations are astronomically low. This has led to more speculative and far more thrilling possibilities. Could the signal be a form of beacon? The Fibonacci sequence is a universal constant, a concept that any technologically advanced civilization, regardless of its biological form, would likely recognize as a clear signature of intelligence rather than natural chaos. Perhaps this star was not just ejected, but was deliberately directed, a targeted projectile carrying a message or a marker. Some theorists even suggest the star itself could be an engineered artifact, a so-called stellar engine, or a probe using the star's mass as a power source or disguise, broadcasting its precise mathematical pattern to announce its presence or trajectory to the cosmos. The Sagittarius sequence forces us to confront the very limits of our scientific paradigms. It presents us with a stark choice. Do we accept an incredibly rare and complex natural explanation? Or do we dare to entertain the possibility that we are witnessing something that transcends natural astrophysics? This signal doesn't just ask us to solve a puzzle, It asks us to question how we define life, intelligence, and our place in a universe that seems capable of producing patterns of both immense violence and impossible elegance. It stands as a humbling reminder that some cosmic mysteries refuse to be easily categorized, lingering in that fascinating space between the known and the unknowable. Following the mathematical elegance of the Sagittarius sequence, our journey takes a turn into the truly bizarre with a signal that seems to defy the very nature of reality as we understand it. Emerging from the constellation Taurus, the signal known as the Taurus tremor, or HVS7, is not a series of pulses or a steady hum, but a constant, low-frequency vibration that exhibits what can only be described as quantum behavior on a macroscopic scale. The most baffling aspect of this signal is its apparent existence in a superposition of states, much like the famous thought experiment of Schrödinger's cat being both alive and dead. Our instruments detect the tremor not as a single, coherent wave, but as 2 or 3 distinct frequency signatures overlapping and interfering with each other, all emanating from the same point in space at the same time. It's as if the signal itself is both a high-pitched whine and a low rumble simultaneously, a phenomenon that should be impossible for a classical astrophysical source. This quantum-like characteristic doesn't just make it unusual, it places the Taurus tremor in a category all its own, a cosmic mystery that seems to blur the line between the quantum world and our everyday reality. The hypervelocity star linked to this quantum conundrum is a magnetically extreme object designated HD 25784. This star is a true cosmic fugitive, blazing a trail out of the galaxy at over 900 kilometers per second. But its incredible speed is almost a secondary feature compared to its truly extraordinary magnetic personality. Spectroscopic analysis has revealed that this star possesses what is known as a multipolar magnetic field, a configuration of stunning complexity. Instead of the relatively simple north-south dipole field that most stars possess, akin to a simple bar magnet, this star's magnetic field is a tangled, chaotic web of multiple poles scattered across its surface. This creates regions of immensely powerful and localized magnetic energy, generating stresses and phenomena that are incredibly difficult to model or understand. The energy stored and released by this convoluted magnetic prison is thought to be the engine powering the tremor, but the mechanism by which it produces such a strange signal remains completely unknown. This brings us to the heart of the theoretical struggle to explain the Taurus tremor. How can a signal from a massive star exhibit quantum properties? One leading hypothesis ventures into the cutting edge of theoretical physics, suggesting that the star's hypervelocity state might be creating conditions where effects of quantum gravity become momentarily significant. Quantum gravity is the long-sought theory that would unite Einstein's general relativity, which governs the very large, with quantum mechanics, which governs the very small. The idea is that the star's immense velocity, a significant fraction of the speed of light, could be warping local spacetime around it in subtle ways. Coupled with the unimaginable pressure and magnetic field strength at its surface, this might be allowing quantum vibrations from the fabric of spacetime itself to leak into our classical reality, manifesting as the superimposed signal we detect. In this scenario, we aren't just looking at a star, we are witnessing a unique natural laboratory where the fundamental rules of the universe are being stress-tested. A less exotic but still fascinating theory focuses on the star's tortured magnetic field. Physicists propose that the chaotic multipolar Chinese letter is constantly snapping and reconnecting in a frantic dance, a process that accelerates particles to near light speed. These particles, trapped in magnetic loops, could then be generating maser emissions, naturally occurring lasers, at radio frequencies. The superposition effect could be an illusion created by relativistic effects. If different clouds of these particles are being accelerated along different magnetic field lines moving at very different velocities relative to us, the Doppler shift could smear a single emission into what appears to be multiple overlapping frequencies. While this explains the multiple states through known physics, it still requires a magnetic field configuration of such complex violence that it pushes the boundaries of what we believe is possible for a stellar object. The torus tremor ultimately stands as a profound reminder of how much we have yet to learn. It challenges the comfortable boundary we've drawn between the quantum realm and the classical world of stars and galaxies, suggesting that under extreme conditions that boundary can become porous. Whether it's a glimpse into quantum gravity or simply a stunningly complex magnetic phenomenon, this signal forces physicists to reconsider the limits of their models. It is a humbling and exhilarating puzzle, a vibration from the depths of space that resonates not just through our telescopes, but through the very foundations of modern physics. If the torus tremor challenged our understanding of physics, the next signal confronts us with a phenomenon that seems to actively resist any form of classification or pattern. Designated HVS 8, this emission has been nicknamed the Ursa Major Mystery for its point of origin within the familiar constellation of the Great Bear. Its most baffling feature is not its frequency or its strength, but the behavior of its polarization. Polarization is the orientation of a light wave's oscillations, and while many cosmic signals have a stable or slowly drifting polarization, the Ursa Major Mystery exhibits no such consistency. Its polarization shifts in a completely random, stochastic manner, flipping between circular, elliptical, and linear states with no discernible rhythm, reason, or repeating sequence. It is as if an invisible hand is constantly and arbitrarily twisting a dial on a cosmic radio, changing the signal's fundamental character faster than we can even track it. This total lack of a pattern makes it impossible to predict and incredibly difficult to analyze, marking it as one of the most chaotic and disordered signals ever detected. The hypervelocity star believed to be the source of this chaotic broadcast only deepens the intrigue. Designated Gaia EDR 3712456789, its trajectory is perhaps the most startling of all. By tracing its path backward across the sky, astronomers made a staggering realization. This star is not from our galaxy at all. Its incoming vector points directly away from the intergalactic void, suggesting it originated in another, smaller galaxy that was cannibalized by the Milky Way billions of years ago. It is an extragalactic immigrant, a celestial visitor from a now-devoured dwarf galaxy, and it was ejected with such tremendous force that it is now traveling through our own galaxy at over 1,200 kilometers per second. This extragalactic origin is crucial, as it means this star was born and ejected under conditions that could be vastly different from those within the Milky Way, potentially involving exotic stellar types or environments we have never before encountered. This extraordinary history fuels the two most compelling theories attempting to explain the signal's random polarization. The first and most profound theory proposes a direct interaction with the universe's most elusive substance, dark matter. As this star travels on its unique path from outside our galaxy, it may be plowing through dense, unmapped clumps or streams of dark matter that are not present in the more well-mixed regions of the Milky Way. Theorists suggest that these dark matter particles, whatever they may be, could be interacting with the star's intense magnetic field in a novel way. Each interaction could momentarily alter the field structure or the properties of the plasma surrounding the star, acting like a random kick that twists the polarization of the emitted signal. In this scenario, the chaotic polarization isn't a property of the star itself, but a flickering shadow, a readout of the invisible dark matter topography it is passing through. We wouldn't be seeing the dark matter, but we would be witnessing its ghostly influence on the signals we can detect. The second theory looks to more conventional, though still exotic, interstellar phenomena. The star's immense speed means it is traversing regions of space that may have wildly varying magnetic field orientations and electron densities. If the signal is being generated in a shock wave at the star's leading edge, a bow shock as it rams through the interstellar medium, then passing through a pocket of magnetized gas with a different alignment could abruptly change the polarization of the emission. The randomness would then be a reflection of the turbulent and unpredictable nature of the interstellar medium itself, a chaotic sea of magnetic fields and plasma that the star is stirring up. While this explanation relies on known physics, it requires a level of magnetic turbulence that is itself unprecedented, suggesting we may be witnessing a new and extreme state of the matter that exists between the stars. The Ursa Major mystery, therefore, forces us to consider that whether the answer lies in the darkness of unknown matter or the turbulence of visible space, our map of the cosmos is still missing fundamental features. Just when we thought the cosmos couldn't present a more intimate mystery, the universe delivers a signal that seems to speak our own solar system's language. Emerging from the constellation Virgo, this emission, designated HVS 9 and nicknamed the Virgo vibration, possesses a harmonic signature so specific and so familiar it sent a wave of disbelief through the astronomical community. The signal is not a random noise or a chaotic pulse. It is a complex set of resonant frequencies, a chorus of distinct tones where each primary frequency and its accompanying harmonics match, with astonishing precision, the orbital periods of the planets in our own solar system. The fundamental vibration aligns with Jupiter's 12-year journey around the Sun, while the overtones correspond to Saturn's 30-year orbit, the 84-year path of Uranus, and even the slow 165-year dance of Neptune. It is as if someone is broadcasting the celestial music of our home, but from a star hurtling through the void thousands of light years away. The sheer statistical improbability of this coincidence is staggering, defying any reasonable expectation of random chance. For a naturally occurring astrophysical signal to not only have multiple clear harmonics, but for those specific frequencies to align perfectly with the orbital cadences of our solar system, is akin to finding a message in a bottle on a distant beach written in your exact native dialect and discussing the weather in your hometown. The odds are so astronomically low that it immediately forces a rigorous re-examination of the data and the instruments themselves. Scientists first had to rule out the most mundane explanation, that this was not a signal from deep space at all, but some form of local interference or a subtle instrumental artifact within the observatory that was somehow mimicking these familiar frequencies. After exhaustive checks, the signal was confirmed as extraterrestrial in origin, leaving researchers with a profound and unsettling puzzle. This leads to the first and most sober scientific explanation, that we are the victims of a monumental yet entirely natural coincidence. The universe is an immense place, and the laws of physics govern the behavior of all celestial bodies. Orbital resonance, where the gravitational influence of one body causes another to orbit at a simple harmonic ratio, is a common phenomenon seen in moon systems and asteroid belts across the galaxy. The argument is that the hypervelocity star, which spectroscopic analysis reveals to be a relatively common G-type star much like our own Sun, is interacting with its own unseen system of planets or a companion star. The resonant frequencies we detect could be the result of complex gravitational interactions within that far-off system, which just happen to produce a set of harmonics that mirror our own solar system's architecture by pure, unimaginable luck. In this view, the Virgo vibration is a breathtaking cosmic echo, a reminder that the same physical processes are at work everywhere, sometimes creating patterns that feel uniquely personal. A more speculative and far more thrilling theory ventures into the realm of what is known as transcension physics, the idea that advanced civilizations might not use radio waves for communication, but instead manipulate the fabric of spacetime itself, using gravity or resonant vibrations as a medium. Proponents of this idea suggest the signal could be a deliberate beacon, a way for an intelligence to broadcast its presence using a mathematical and astronomical language it assumes any spacefaring species would understand, the fundamental rhythms of a planetary system. The hypervelocity star in this scenario might not even be the true source, but merely a convenient celestial landmark near which such a beacon has been placed, its incredible speed making it a notable signpost in the galactic vastness. It is a message not in a bottle, but in the very vibrations of reality, waiting for a species that has learned to read the music of the spheres. Between the extremes of pure chance and deliberate communication lies a third, profoundly philosophical possibility, that this signal is a hint of a deeper, fundamental connection in the cosmos, a concept sometimes called cosmological resonance. This idea proposes that the structure of our solar system is not a random arrangement but part of a larger harmonic pattern that repeats throughout the universe. The specific ratios of planetary orbits could be a natural outcome of universal constants and the dynamics of protoplanetary disk formation, meaning that many star systems might settle into similar resonant patterns. The Virgo vibration, then, would not be a message for us, but a glimpse into a universal symphony, an underlying order to the cosmos where many stellar systems hum the same tune. We are not hearing an echo of our own system, but rather listening to another member of the same cosmic choir, confirming that the music we call home is in fact a universal composition. This signal challenges not just our search for answers, but our very perception of whether a coincidence can ever be truly random in a universe bound by the same fundamental laws. Leaving behind the cosmic melody of Virgo, we arrive at a signal that feels less like a natural phenomenon and more like a deliberate transmission. The Cassiopeia code, designated HVS-10, stands apart from the chaotic or harmonic signals we've explored so far. Its most immediately striking feature is its sophisticated modulation, a complex pattern of amplitude and frequency shifts that doesn't resemble the random noise of stellar winds or the steady pulse of a rotating neutron star. Instead, the signal's architecture appears to be layered, carrying what some analysts describe as a nested or encoded structure. Upon deeper analysis, researchers discovered that key intervals within the signal's modulation correspond with astonishing accuracy to the values of fundamental mathematical constants. The ratio between two dominant frequencies precisely matches the golden ratio, approximately 1.618, a number revered for its appearance in art, nature, and mathematics. Furthermore, the duration of specific pulse trains aligns with the first 10 digits of pi, and the signal's bandwidth modulation appears to echo the base of the natural logarithm, known as Euler's number. This mathematical fingerprint is so pronounced and so meticulously embedded within the signal's fabric that it defies easy dismissal as mere cosmic coincidence. The hypervelocity star believed to be the source of this enigmatic broadcast, a yellow-white subgiant designated HD 209458, presents its own set of profound mysteries. This star is a true cosmic exile, racing toward the outer reaches of the galaxy at a velocity of over 800 kilometers per second, but its journey is only part of the story. When astronomers turned their spectrographs toward it to analyze its composition, they discovered something truly bizarre. Its atmosphere contains highly anomalous isotope ratios. Isotopes are different forms of the same element, varying in the number of neutrons in their atomic nucleus. In this star, the ratios of certain isotopes, particularly those of iron, nickel, and silicon, are completely off the scale compared to the standard abundances found in our solar neighborhood or anywhere else in the galactic disk. These specific isotopes are known to be produced in immense quantities only during the most violent and rare stellar events, such as the merger of two neutron stars or a specific type of supernova involving a white dwarf. The presence of these isotopes in such abnormal concentrations coating the star's surface suggests it was either born in an incredibly exotic environment or it has been recently and thoroughly polluted by a nearby cataclysm of almost unimaginable power. This combination of a mathematically sophisticated signal and a chemically anomalous star has sparked one of the most intense and polarized debates in modern astronomy, centering on the question of natural versus artificial origins. The scientific consensus, as it stands, leans heavily toward a natural explanation, albeit an extraordinarily complex and rare one. The prevailing theory suggests that the star's anomalous isotopes are the key. The cataclysmic event that produced them, likely a neutron-star merger, occurred very close to this star. The incredible influx of energy and newly forged heavy elements from this event could have triggered a series of profound and unstable nuclear reactions within the star's own interior. Theorists propose that this could have created a self-regulating, oscillating fusion engine in its core, whose resonant frequencies and energy release patterns are governed by the fundamental laws of hydrodynamics and nuclear physics. In this view, the mathematical constants we detect are not a message but a natural byproduct. The star is essentially ringing like a bell, and the notes it plays are dictated by the immutable laws of mathematics, which would be the same anywhere in the universe. The code is simply physics expressed with a clarity and purity we rarely have the opportunity to observe. However, a small but vocal minority of scientists and theorists argue that the natural explanation, while possible, strains credulity due to the sheer precision and layered complexity of the signal. They point out that while natural processes can produce harmonics, the Cassiopeia code exhibits a deliberate sequencing of these mathematical constants that appears to be packaged information. This camp posits a more radical hypothesis that the cataclysmic event was not just a random accident but a purposeful act. Could an advanced civilization have somehow engineered the neutron-star merger, or perhaps simply taken advantage of it, using the tremendous energy released to power a beacon? The hypervelocity star, already ejected from its birthplace, becomes the perfect carrier for this message, a wandering monument broadcasting its creator's knowledge of fundamental mathematics across the galaxy. The anomalous isotopes in this scenario are not just pollution but a signature, a forensic clue pointing to the technological means used to create the transmitter. This theory remains firmly on the fringe, but it underscores the profound challenge the Cassiopeia code presents. It sits right on the knife's edge between the known limits of natural astrophysics and the boundless possibilities of the unknown, forcing us to continually question where that line truly lies. Moving from the mathematically charged mystery of the Cassiopeia code, we now turn our attention to a signal that seems to defy one of astronomy's most reliable tools, the Doppler effect. The phenomenon, designated HVS 11 and nicknamed the Draco drift, was first detected emanating from a hypervelocity star speeding through the constellation Draco. At first, astronomers assumed the signal's changing frequency was a straightforward case of the Doppler shift, the same effect that makes a passing ambulance's siren change pitch. As a source moves toward you, its waves are compressed, raising the frequency. As it moves away, the waves are stretched, lowering it. This principle is fundamental to measuring the velocity of stars and galaxies. The Draco drift, however, behaves in a way that completely upends this expectation. Its frequency doesn't change at a linear rate consistent with the star's constant high velocity. Instead, the drift is non-linear, almost languid, shifting in a smooth, graceful curve that accelerates and decelerates in a pattern utterly disconnected from the star's actual motion. It's as if the signal is wandering on its own accord, drifting through the radio spectrum without a care for the laws of motion that govern its source. The hypervelocity star linked to this anomaly, a massive O-type giant designated BD plus 63 degrees 1371, is itself a spectacular object. It is barreling through the galactic halo at a velocity exceeding 1,100 kilometers per second, a speed so tremendous it will inevitably lead to the star's exile into intergalactic space. This immense velocity means the relativistic Doppler effect must be taken into account. At speeds approaching a significant fraction of the speed of light, Einstein's theory of relativity adds a layer of complexity to the standard Doppler calculations, requiring precise corrections for time dilation. Astronomers can account for this with exquisite accuracy, but the Draco drift's frequency shift stubbornly refuses to align with any model that combines the star's measured velocity with known physics. The drift is there, it's measurable, but it follows its own mysterious rhythm, creating a clear and vexing disconnect between the star's movement and its signal's behavior. This bizarre discrepancy has led theorists to propose explanations that venture into the profound implications of extreme velocity. One compelling hypothesis suggests that at such phenomenal speeds, the star is not merely moving through space-time, it is significantly warping it. According to general relativity, mass and energy tell space-time how to curve, and that curvature tells mass and energy how to move. A star of significant mass traveling at a significant fraction of light speed carries immense kinetic energy, and this energy itself contributes to the warping of the local space-time metric around the star. The Draco drift, in this view, might not be a simple Doppler shift at all. Instead, it could be a direct measurement of the subtle, shifting distortions in space-time through which the signal must travel on its way to us. The signal's frequency is being altered not just by motion, but by the changing geometry of space itself in the star's immediate vicinity, an effect that would be unique to an object of this mass moving at this speed. A second, even more mind-bending theory looks beyond the star itself to the medium it is traveling through. The interstellar and intergalactic medium is not a perfect vacuum. It is filled with a sparse soup of particles, fields, and dark matter. The leading idea here is that the star's magnetic field, stretched and intensified by its hypervelocity state, is interacting with this medium in a novel way, perhaps creating a localized region of polarized plasma that acts like a lens. As the star moves, the properties of this lens could be changing, gradually altering the path length and effective propagation speed of the radio waves. This would impose an additional, gradual frequency shift on top of the standard Doppler effect, creating the observed drift. We are not seeing a challenge to relativity, but rather a complex amplification of its effects through an environment that is being radically altered by the star's passage. Ultimately, the Draco drift presents a fundamental challenge to our basic toolkit for interpreting the cosmos. For over a century, the Doppler effect has been one of the most trusted instruments in the astronomer's arsenal, used to discover exoplanets, measure the expansion of the universe, and track the motions of stars. The Draco drift forces us to admit that under the most extreme conditions, this trusted tool may require a new set of calibrations, or that we are witnessing the signature of physical processes that only reveal themselves at the very limits of velocity and energy. It is a humbling reminder that even our most fundamental assumptions about how the universe works must constantly be tested against the evidence, especially when that evidence comes from the most extreme and unforgiving environments imaginable. While the Draco drift challenges our understanding of motion and frequency, the next signal presents a temporal puzzle, a broadcast from the past that insists on repeating itself. Designated HVS-12, the signal known as the Leo loop is the cosmos's most patient messenger. For years, sometimes even decades, its point of origin in the constellation Leo remains utterly silent, offering no hint of the activity to come. Then, without warning, the signal erupts into existence. Its most captivating feature is not its frequency or its strength, but its content. It transmits an identical, complex pattern of pulses and modulations every single time it activates. It is a perfect cosmic echo, a recording played back with such precision that each reactivation is a carbon copy of the last, down to the most minute detail. After broadcasting its message for a period of months, it once again falls completely silent, entering another hibernation of indeterminate length, leaving astronomers to wonder when, or if, the loop will begin again. The hypervelocity star associated with this cyclical broadcast is a true wanderer, designated TOC 149234567. Its journey through the galaxy is as unusual as the signal it seems to produce. Unlike the near-linear trajectories of most hypervelocity stars, which streak toward intergalactic space like bullets fired from a rifle, this star's path is a graceful, sweeping arc. Through precise astrometric measurements from observatories like Gaia, astronomers have mapped its motion and found it is tracing a wide, parabolic curve through the galactic halo. This arcing trajectory is highly unusual. It suggests the star is not on a simple escape route, but is instead being subtly influenced by a massive, unseen gravitational force, its path bending as it journeys through the galaxy's dark matter halo. This unusual arc is central to unraveling the mystery of the looping signal. The primary natural theory posits that this star is not traveling alone, but is the dominant member of a binary system that survived its initial ejection. The companion, however, is not a typical star. Theorists propose it is an incredibly dense and inert stellar remnant, most likely a white dwarf with a highly elongated, decades-long orbit. For most of this orbit, the two bodies are too far apart for significant interaction, and the system remains quiet. But as the white dwarf swings in for its closest approach, its gravity triggers cataclysmic events on the primary star's surface, perhaps ripping material from its atmosphere or causing massive stellar flares. This period of intense activity generates the identical radio signal each time. The star's arcing galactic trajectory and the companion's orbital period would thus be locked together, creating the precise, multi-year cycle of silence and activity that we observe. The loop is not a message but a clock ticking to the rhythm of a distant, invisible orbital dance. A more speculative and profound theory looks beyond a physical companion to the very fabric of the universe. Some cosmologists have proposed that the Leo loop could be evidence of a gravitational memory effect. The concept suggests that space-time itself can retain a kind of imprint or memory of a massive object's passage. The theory goes that this particular hypervelocity star experienced an immensely traumatic gravitational event in its past, perhaps a near miss with the supermassive black hole that ejected it. This event could have created a standing wave or a kink in the local space-time geometry that travels along with the star. Periodically, as the star moves through regions of varying gravitational potential in its arcing path, this kink could be excited or activated, much like a vibrating string being plucked. This excitation would release energy in a very specific repeating pattern, creating the identical signal we detect. In this breathtaking scenario, we are not just detecting a star's emission, but listening to the faint, recurring echo of a black hole's gravitational roar, a memory frozen in space-time that periodically reminds us of its existence. This brings us to one of the most temporally perplexing signals in our catalog, an emission that seems to defy the unbreakable law of cause and effect. Originating from a star in the constellation Aquarius, the signal designated HVS-13, or the Aquarius anomaly, presents a paradox that has left physicists both intrigued and deeply unsettled. The anomaly itself is a specific type of radio burst, a sharp, energetic spike that has on multiple occasions been recorded by our solar observatories. The baffling part is its timing. These radio bursts have been observed to occur approximately 48 to 72 hours before a corresponding spike in solar flare activity is detected erupting from our own sun. It's as if the star is sending a warning, a cosmic heads-up that arrives days before the event it seems to predict. This correlation is not a one-off coincidence. It's a pattern that has been documented across several solar cycles, creating a statistical relationship that is incredibly difficult to ignore or dismiss as random chance. The hypervelocity star linked to this impossible forecast is a Sun-like G-type star designated Gliese 876, located almost exactly 200 light-years from Earth. This distance is the core of the temporal impossibility. As dictated by Einstein's theory of relativity, nothing, not even information, can travel faster than the speed of light. A signal from a star 200 light-years away is by definition a message from 200 years in the past. We are seeing that star as it was when Napoleon was alive. For a signal from that star to be causally linked to an event on our sun happening now, the information would have to arrive 200 years before the cause, effectively traveling backwards in time. This violation of causality is so fundamental to our understanding of physics that the scientific community has approached the Aquarius anomaly with extreme skepticism, prioritizing a search for errors or more mundane explanations. The primary and most rigorous line of inquiry has focused on the possibility of a measurement artifact or a subtle form of data contamination. Could the signal be generated locally within our own solar system, perhaps by a previously unknown interaction between the solar wind and a planet's magnetosphere that just happens to mimic a deep space radio burst? Perhaps the timing is a psychological illusion, a form of confirmation bias where astronomers, noticing one coincidence, begin to unconsciously seek out and emphasize subsequent correlations while ignoring the many times the signal appears with no solar event following it. Extensive reviews of the data, however, have so far failed to find a convincing instrumental or statistical flaw. The correlation persists, forcing scientists to consider explanations that, while highly speculative, venture into the deepest realms of theoretical physics. The most theoretically daring explanation involves the bizarre phenomenon of quantum entanglement, a property where two particles can become linked in such a way that the state of one instantly influences the state of the other, regardless of the distance separating them. Some physicists have proposed that the hypervelocity star Gliese 876 and our own sun might share a deep, fundamental connection. Perhaps they were born from the same stellar nursery billions of years ago, and their primordial particles remain quantum entangled on a macroscopic scale. In this view, a massive solar flare isn't caused by the signal from the star. Both the flare and the signal are simultaneous effects of a single, deeper cause happening at a quantum level. The signal doesn't travel faster than light. The connection is instantaneous, a spooky action at a distance that pre-establishes a correlation we then measure with a delay. While this idea elegantly sidesteps the faster-than-light problem, the notion of maintaining quantum entanglement between two entire stars across such vast distances and timescales is considered virtually impossible by most physicists, as these states are notoriously fragile and easily disrupted. A less revolutionary but still profound theory suggests we are misinterpreting the signal's origin point. The Aquarius anomaly might not be emanating from the star itself, but from a point much closer to us along the same line of sight. Imagine an unknown, undetectable object, a rogue planet, a dense cloud of dark matter, or a primordial black hole located somewhere in the interstellar space between us and Gliese 876. This object could be acting as a relay or a lens. It might be sensitive to solar activity and emit its own signal in response, which we then detect and mistakenly attribute to the distant star. The timing could be a complex illusion created by the geometry of this hidden object's path and its interaction with both our solar system and the light from the hypervelocity star. We aren't breaking causality, we are simply misunderstanding the map, attributing a local phenomenon to a distant source. The Aquarius anomaly ultimately stands as a humbling reminder that our grasp of the universe is still incomplete. It challenges the very bedrock of classical physics while simultaneously offering a tantalizing, if unproven, glimpse into a potential quantum interconnectedness of cosmic bodies. Whether it is a simple error in measurement, a complex illusion of geometry, or a window into a deeper layer of reality, this signal forces us to confront the limits of our knowledge and remain open to the possibility that the cosmos still holds mysteries that defy our current understanding of time and connection. Just as the Aquarius anomaly challenges our understanding of time, the next signal on our list presents a cosmic game of hide and seek that has left astronomers utterly perplexed. Known as the Scorpio shadow, or HVS-14, this signal possesses a bizarre and unnerving characteristic. It periodically vanishes without a trace. Its disappearance is not random or gradual, but instead occurs with the precise regularity of a celestial clock, only to reappear just as suddenly once a specific window of time has passed. After years of painstaking observation, researchers made a stunning correlation. These blackout events occur exclusively during specific periods when the constellations of Scorpius and Ophiuchus align directly between Earth and the hypervelocity star's location in deep space. It's as if the star is being eclipsed not by a solid object, but by the combined mass and space of these constellations themselves, a concept that defies conventional astronomy, as the stars within a constellation are light years apart from each other and cannot form a physical barrier. The star responsible for this elusive broadcast is a true celestial veteran, an ancient red giant designated HRP 85922. Spectroscopic analysis reveals it to be one of the oldest stars ever identified, a population 2 star that originated in the galactic halo during the Milky Way's infancy, billions of years before our own sun ignited. This ancient star is on a final high-speed journey, ejected from its home eons ago and now traveling at over 700 kilometers per second. Its great age is a crucial piece of the puzzle, as it means this star has been traveling through the galaxy for an immense span of time, passing through regions of space with vastly different compositions and gravitational landscapes. The mystery lies in why its signal is so vulnerable to a specific, repeating alignment that involves foreground stars that are, for all intents and purposes, not actually in its way. The most scientifically grounded explanation for this periodic vanishing act involves a complex and dynamic form of gravitational lensing. While the constellations themselves are not physical barriers, the line of sight between us and HRP 85922 does pass through the vast gravitational influence of the Scorpius-Centaurus association, one of the closest OB associations to our solar system. This region is filled with massive young stars, molecular clouds, and a complex web of gravitational fields. Theorists propose that a specific, delicate alignment of these foreground masses could be creating a perfect gravitational lens that, instead of magnifying the signal, actually diverges it. Imagine a complex set of lenses that, when aligned in just the right way, scatters light rather than focusing it. This gravitational mirage would effectively defocus the radio waves from the hypervelocity star, causing its signal to spread out and drop below our detection threshold for the duration of the alignment. The precision required for this effect is astronomical, but not impossible given the immense timescales involved. An alternative and equally compelling theory looks to the interstellar medium for an answer. The space between stars is not empty, it is filled with a tenuous soup of gas, dust, and plasma. The line of sight through the constellations of Scorpius and Ophiuchus traverses a region known to contain several dense, albeit invisible, molecular clouds. These clouds are composed mostly of hydrogen molecules and can contain regions of ionized plasma that are excellent at absorbing specific radio frequencies. The hypothesis is that as the Earth, the foreground constellations, and the distant hypervelocity star move through their respective orbits, our line of sight periodically passes directly through one of these dense, cold clouds. For a few weeks or months, this cloud acts like a cosmic fog, absorbing the specific frequency of the Scorpio shadow signal. The reason no other star exhibits this behavior could be a matter of unique frequency. The signal from HRP 85922 might be emitted at a wavelength that is particularly susceptible to absorption by the specific molecular composition of these interstellar clouds, a perfect storm of emission and absorption that we don't see elsewhere. What truly sets the Scorpio shadow apart and cements its status as a profound anomaly is its utter uniqueness. In all our surveys of the sky, monitoring countless variable signals from pulsars, quasars, and other hypervelocity stars, we have never witnessed another instance of a signal disappearing so completely and so predictably due to a foreground stellar alignment. This singularity suggests that the explanation requires a rare combination of factors: a hypervelocity star of a specific age and composition emitting a signal at a very specific frequency, traveling on a trajectory that periodically aligns it with a region of space that possesses just the right gravitational or interstellar properties to interrupt it. The Scorpio shadow is not just a signal, it is a cosmic alignment of countless variables, a fleeting window into the intricate and often invisible structure of our galaxy, reminding us that sometimes the most profound mysteries are found not in what we can see, but in what periodically and predictably disappears from view. Amidst the unpredictable chaos and exotic theories of our previous signals, the Pisces pulse arrives as a moment of stunning, almost mechanical perfection. In the vast cosmic symphony of random noise and erratic bursts, this signal stands apart for its unwavering metronomic consistency. Designated HVS 15, it emits a sharp, clean pulse of radio energy with a period of exactly 1.337 seconds, a rhythm it has maintained without the slightest deviation for over 3 decades of continuous observation. This isn't the approximate beat of a pulsar that slowly spins down over millennia. It is a level of precision that rivals the most accurate atomic clocks on Earth, a steady cosmic heartbeat that has ticked through the void with incomprehensible reliability. The hypervelocity star linked to this impeccable timekeeping is yet another cosmic runaway, designated Gaia DR 34567891. It is a main sequence star similar in many ways to our own Sun, yet it is fleeing the galaxy at a constant velocity of 800 kilometers per second. This combination is what makes the Pisces pulse so profoundly baffling. Main sequence stars like our Sun are simply not capable of generating such a rapid and precise signal. Their interiors are turbulent balls of fusing plasma, their surfaces roil with magnetic storms and convective currents. They are the definition of chaotic dynamic systems. To produce a signal with a period of just over 1 second requires an object that is incredibly small, incredibly dense, and rotating with phenomenal speed. This is the defining characteristic of a neutron star, the collapsed core of a star that went supernova, often no larger than a city yet containing more mass than our Sun, spinning hundreds of times per second. This presents astronomers with an impossible contradiction. We are looking at a star that, by all spectral classification, is a normal main sequence star, but it is broadcasting a signal that can only come from a neutron star. So how can one object possess the properties of both? The leading theory attempts to resolve this paradox by proposing that the star we see is not the source of the signal at all, but rather a veil hiding the true engine. The hypothesis suggests this hypervelocity star is actually part of a binary system, with the primary, visible star orbiting an unseen neutron star companion. In this scenario, the perfectly timed pulses are indeed coming from the rapid rotation of the neutron star, its lighthouse-like beam sweeping across space with every turn. The visible star, however, acts as a natural shield, its atmosphere and magnetic field occasionally eclipsing or filtering the neutron star's powerful radio burst. This interaction could be modulating the signal, perhaps amplifying certain frequencies or creating the clean, sharp pulse profile we detect, all while the main sequence star's light dominates the optical view, effectively camouflaging the dense remnant at its heart. An even more exotic theory suggests we might be witnessing a stellar zombie, an object that has somehow cheated death. Could this main sequence star have once been the companion to a star that went supernova? The cataclysm would have given it its tremendous velocity, hurling it away from the explosion site. But perhaps the supernova WAS Chinese letter, a fizzled explosion that failed to completely unbind the progenitor star. Instead of creating a separate neutron star, the collapse may have resulted in a neutron star core forming inside a still intact stellar envelope, a Thorne-Zitkow object. These theoretical hybrids are thought to be unstable and short-lived, but if one existed, it could potentially explain the combination of a main sequence appearance with the internal engine of a neutron star, its rotations transmitting pulses through the outer layers of the star. The true enigma of the Pisces pulse is its unshakable consistency. Even a binary system or a stellar hybrid would be subject to tiny, measurable changes in its pulse period over decades due to gravitational wave emission or mass transfer. The fact that this signal has not slowed down or sped up by even a fraction of a millisecond in 30 years suggests a stability that is almost unnatural. It points to a system that is perfectly balanced, a cosmic flywheel whose rhythm is immune to the external forces and internal processes that affect every other known object in the universe. This perfection is what makes the signal so compelling and so unsettling. It feels less like a natural phenomenon and more like a piece of cosmic engineering, a clock set ticking at the dawn of time that continues to mark the seconds long after its makers are gone. This brings us to a signal that seems to be speaking to itself, a cosmic call waiting for its own reply. Discovered emanating from the constellation Aries, the signal designated HVS-16, or the Aries Echo, presents a phenomenon that is as baffling as it is unique. Unlike a simple pulse, this emission arrives not as a single event, but as a primary burst followed by a series of distinct, fading repetitions, each one an exact duplicate of the original, but arriving at our telescopes with precise time delays. It's as if the signal is bouncing off of some unseen surface in the depths of space, creating a cascade of echoes that gradually diminish in strength but remain perfectly faithful to the initial broadcast. The delay between the original signal and its first echo is a consistent 4.2 seconds, with each subsequent echo following at that same exact interval, creating a rhythmic decay that has been observed on multiple occasions. What makes the Aries Echo so profoundly mysterious is the complete and utter lack of any physical object that could act as a reflector. Astronomers have meticulously scanned the region of space along the signal's projected path, searching for anything, a nebula, a dust cloud, a rogue planet, even a black hole's accretion disk, that could serve as a surface to bounce this radio wave back toward us. They have found absolutely nothing. The path is a clear, empty corridor of interstellar space, a near-perfect vacuum for light years in every direction. This absence of a reflecting body transforms a curious observation into a deep cosmological puzzle, forcing us to ask how an echo can exist without a wall to create it. The hypervelocity star linked to this self-echoing broadcast is a true cosmic speedster, an immense blue giant designated HD 62549. This star is racing away from the galactic plane at a velocity that places it squarely in the realm of relativistic effects, traveling at over 90% of the speed of light. This incredible velocity is the key that unlocks the most compelling theoretical explanations for the echo. One leading hypothesis delves into the bizarre behavior of light and space at such extreme speeds. According to special relativity, as an object approaches the speed of light, time dilation effects become profound. Theorists suggest that the signal itself, as it is emitted from the star's powerful magnetosphere, could be interacting with its own wake in the fabric of space-time. The star's immense gravity and velocity might be creating a sort of bow shock not in gas, but in the geometry of space itself, and the signal could be catching up to and interacting with this relativistic disturbance, creating the illusion of a delayed echo from our stationary perspective. An even more exotic theory proposes that the echo is not an illusion of motion, but a genuine glimpse into hidden dimensions, a concept drawn from string theory. This idea suggests that the hypervelocity star's immense energy and speed might be momentarily allowing its radio emissions to leak into a compactified higher spatial dimension. In this higher dimensional space, the shortest path between 2 points isn't a straight line, but a different kind of curve. The echo we detect could be a portion of the signal that has taken this longer, higher dimensional shortcut, arriving back in our familiar 3-dimensional space a few seconds after the main burst. We wouldn't see a reflecting object because the reflection isn't happening in our reality. It's happening through a geometric landscape we cannot perceive, making the Aries echo a potential, though highly speculative, fingerprint of the universe's hidden architecture. This signal challenges the very definition of an echo. We are conditioned to think of an echo as a sound wave bouncing off a mountain, but in the relativistic and potentially multi-dimensional theater of deep space, the rules are rewritten. The Aries echo might not be a reflection of a thing, but a reflection of an event, the event of the star's own incredible passage through the cosmos. It is a ripple in space-time that manages to lap upon its own shore, a message from a star that is so extreme. Its very motion creates a mirror in the void, allowing us to hear its voice more than once and ponder the strange and hidden geometry of the universe it travels through. Shifting from the self-echoing mystery of Aries, our next signal presents a cosmic rhythm that feels like the universe itself is breathing. Designated HVS-17 and nicknamed the Libra libration, this phenomenon exhibits a slow, gentle oscillation in its signal strength, a smooth ebb and flow that repeats with a precise period of almost exactly 417 days. Unlike the erratic variations of the Gemini ghost or the sharp pulses of the Pisces pulse, the libration's amplitude modulation is a model of perfect sinusoidal harmony, a clean, wave-like pattern that rises and falls with the serene regularity of ocean tides. This tidal characteristic is the key to its mystery, as the signal appears to be swaying in response to a gentle, rhythmic gravitational pull from something that simply isn't there. The hypervelocity star at the center of this gentle cosmic dance is a solitary traveler designated Gaia 3814566729. This star is on a profoundly lonely journey, hurtling through what is considered one of the most barren and empty regions of the galactic halo, a vast desert of space where the density of stars and visible matter is almost zero. Its trajectory has been mapped with extreme precision, and it shows the star is moving in a near-perfect straight line, unperturbed by any large gravitational sources like star clusters or dark nebulas for millions of light years in every direction. This isolation is what makes the libration so inexplicable. The star is sailing through a vacuum, yet its signal behaves as if it is being gently tugged by an invisible force, rocking back and forth in a way that perfectly mimics the gravitational influence of a close, orbiting companion. This contradiction has led astrophysicists to a startling conclusion. The star's path is not truly empty. The precise, tide-like quality of the libration strongly suggests the presence of significant amounts of it, exerting a gravitational influence. But since our telescopes reveal absolutely nothing in the vicinity, that mass must be invisible. This is where the theory of dark matter takes center stage in a uniquely testable way. The leading hypothesis proposes that Gaia 3814566729 is not sailing through a void, but is instead passing through a dense, localized clump or a flowing stream of dark matter. As the star moves through this invisible cloud, the gravitational pull from the concentrated dark matter would subtly alter the environment around the star, perhaps squeezing its magnetosphere or influencing how its radio emissions are generated. The 417-day cycle would then correspond to the time it takes the star to traverse the entire width of this dark matter clump, with the signal's strength waxing and waning as it moves into, through, and out of the region of strongest influence. An alternative but equally fascinating theory suggests we might be witnessing the gravitational echo of a primordial black hole. These hypothetical objects, thought to have formed in the dense early universe, could range in mass from a small asteroid to a large planet, all compressed into a singularity with no observable light. A black hole with a mass several times that of Jupiter, orbiting the star at a great distance, could easily create the observed tidal pull on the signal without being detected by any means other than its gravity. The libration would be the direct result of this dark companion's steady gravitational rhythm. The challenge with this theory is that such a black hole would also noticeably perturb the star's own motion, causing it to wobble slightly on its path, a wobble that has not been observed, making the dark matter clump a more likely, though perhaps less exotic, culprit. The profound implication of the libration is that it may provide us with our first ever method of mapping the small-scale structure of dark matter. We know dark matter exists on the vast scale of galaxies, but its distribution on the scale of solar systems has been entirely theoretical. This signal acts like a sonar ping in the cosmic deep, revealing the presence of invisible structures by the way they distort the signals from stars passing through them. We are no longer just inferring dark matter's existence from its large-scale gravitational effects. We might be seeing its fine-grained texture for the very first time, reading the subtle ripples it creates on the surface of a hypervelocity star's broadcast. The libration offers a tantalizing glimpse of a new form of astronomy, one where we don't just look at the light in the universe, but learn to read the shadows cast by the darkness. Just when we thought we had categorized the strange behaviors of these cosmic speedsters, the universe delivers a signal that seems to change its very nature depending on how we choose to look at it. Designated HVS 18, the Capricorn conundrum is a master of disguise, presenting two completely different personalities to our most powerful telescopes. When observed through the radio dishes designed to capture its emissions, the signal appears as a steady, coherent hum, a narrow-band transmission that suggests a stable, well-defined process at work within the star. Yet, when astronomers turn their optical telescopes toward the same point in space to study the star's visible light, the story changes dramatically. The optical data reveals a star in constant, violent turmoil, with its brightness flickering erratically and its spectrum shifting wildly. It's as if the radio signal is the calm, composed voice of the star, while its visible light reveals a body racked by invisible storms, creating a baffling Jekyll and Hyde paradox in the depths of space. This bizarre dichotomy is centered on a hypervelocity star that is itself a study in contradiction. Designated HD 204861, this star is a massive, hot B-type subgiant, screaming through the constellation Capricornus at over 900 kilometers per second. Its spectrum, the unique fingerprint of its chemical composition and physical state, is where the mystery deepens exponentially. The spectral analysis reveals the presence of deeply unusual and transient absorption lines. These are the dark bands in a spectrum that indicate specific elements in the star's atmosphere are absorbing light at certain wavelengths. In this case, the lines appear and disappear on timescales of mere hours, and they correspond to highly ionized, heavy elements like europium and dysprosium metals that typically require immense energy and exotic conditions to form and become so stripped of their electrons. This suggests an atmosphere not in equilibrium, but one being subjected to tremendous, fluctuating forces that we cannot directly observe. The immediate and most conservative explanation for the conundrum points the finger not at the star but at our own technology. This theory of instrumental illusion argues that the apparent difference between the radio and optical views is a classic case of observational bias. Radio telescopes and optical telescopes operate on vastly different principles and timescales. A radio dish might integrate data over hours to build up a clear signal, effectively smoothing out any rapid variations into a steady hum. An optical telescope, however, can take rapid, high-resolution snapshots of the star's visible light, capturing every sudden flare and dip. In this view, the star is consistently chaotic, but our radio instruments are simply not fast enough to see it, creating the illusion of a calm radio voice. The strange spectral lines could then be explained by complex stellar shocks or magnetic phenomena that our current models don't adequately account for, a gap in our understanding rather than a flaw in physics. However, if the effect is proven to be real and not an illusion of measurement, the implications become extraordinarily profound. We are forced to consider that we might be witnessing a form of physics where the act of observation itself influences the outcome, a macroscopic example of the quantum observer effect. In the quantum world, particles exist in a probability state until they are measured, at which point they choose a definite state. Could the immense energies and velocities involved in this hypervelocity star's environment be scaling up this quantum weirdness to a stellar level? The theory proposes that the process generating the radio signal is fundamentally quantum in nature, perhaps involving entangled particles in the star's corona. The stable, coherent radio hum is the base state, but the act of observing it with optical light bathing the star in photons to take its picture could be directly disrupting that quantum process, collapsing it into a classical, chaotic state that we then see as flickering and shifting spectral lines. We wouldn't just be observing the star, our observation would be an active participant in its behavior. A less radical but still groundbreaking theory looks to the star's magnetic field as the source of the duality. This star could possess a magnetosphere of such complex and intense structure that it acts like a cosmic filter or a prism for different types of radiation. The radio waves generated deep within twisted magnetic loops might be able to escape along certain stable field lines, giving us a clean, coherent signal. The visible light, however, originating from the turbulent photosphere below, has to fight its way through a chaotic canopy of magnetic storms and energetic particle showers, becoming scrambled and modulated before it reaches us. In this scenario, the two views aren't contradictory. They are simply looking at different layers of a deeply complex object. The radio signal shows us the ordered structure of the magnetic cage, while the optical light shows us the chaos of the prisoner trapped inside. The Capricorn conundrum ultimately forces a humbling realization that a star is not a simple ball of gas, but a multi-layered entity, and depending on how we choose to look, we might see only one facet of its incredibly complex and dynamic nature. The journey through cosmic anomalies now leads us to a signal that feels less like a natural phenomenon and more like a message waiting to be decoded. Known as the Cancer Cryptic, this emission stands out not for its power or its persistence, but for the intricate mathematical architecture woven into its very fabric. Designated HVS 19, it broadcasts from a hypervelocity star designated Gaia 23405067889, a sun-like star racing through the constellation Cancer at 750 kilometers per second. What makes this signal so captivating is its sophisticated modulation. Its amplitude and frequency shift not randomly, but in a series of discrete, distinct steps. When researchers analyzed the timing and spacing of these shifts, they made a breathtaking discovery. The pattern follows a precise sequence of prime numbers. The durations of the signal's high power states are prime numbers of milliseconds, and the intervals of silence between them are also primes, creating a nested, layered pattern that is statistically impossible to attribute to chance. It's a broadcast that feels intentionally crafted, a cosmic cipher that seems to be using the universal language of mathematics to ensure its complexity is recognized. The statistical significance of this prime number sequencing is overwhelming, defying all conventional models of natural astrophysical emissions. Astronomers ran extensive probability calculations, comparing the signal's structure to millions of simulated random patterns. The odds of such a precise prime number sequence emerging from stochastic noise were calculated to be less than 1 in several trillion, a clear indicator that this is not a product of chaotic stellar processes. Natural cosmic signals often exhibit harmonics or periodicities, but these are typically based on simple ratios or fundamental physical constants like pi or the golden ratio. The use of a non-repeating, infinite sequence of primes is a different category entirely. Primes are fundamental to mathematics, but they are not a common feature in physical vibrations or orbital resonances. This distinct choice is what fuels the intense scientific debate at the heart of the Cancer cryptic, pushing researchers to consider explanations that stretch from the outer limits of natural physics to the frontier of speculative science. The primary scientific theory, championed by those seeking a natural explanation, proposes an incredibly rare and complex form of resonant stellar oscillation. This camp suggests that the hypervelocity star possesses a highly unusual internal structure, perhaps with a crystallized or densely packed core resulting from its violent ejection history. As seismic waves, massive stellar earthquakes ripple through this complex interior, they could be exciting a set of overtones or standing waves whose frequencies are determined by the star's precise dimensions and density. If these dimensions are related to prime numbers in a specific way, the resulting harmonic series could theoretically produce a prime number-based pattern in the energy released. In this view, the signal is a natural, albeit astonishingly rare, stellar heartbeat, its rhythm dictated by the unique and immutable physical properties of the star itself. We are not hearing a code, but the pure, undistorted music of a star's architecture, a song based on the fundamental primes of mathematics. However, a significant number of researchers find this natural resonance theory insufficient, arguing that it requires a cascade of perfect and highly improbable conditions to align. This has led to the more provocative theory of intentional encoding. The use of prime numbers is particularly compelling in this context because primes are often considered a potential, universal language for interstellar communication. Unlike arbitrary symbols or human-centric references, prime numbers are a mathematical truth, independent of biology, culture, or location in the universe. Any technologically advanced civilization would almost certainly recognize their significance. The hypothesis is that the signal's modulation is not a natural vibration but a constructed message, a beacon designed to capture attention by demonstrating a clear command of mathematics and information theory. The hypervelocity star in this scenario might not be the true source but could be acting as a natural power source or a landmark, with a sophisticated transmitter situated nearby, perhaps on a planet or a deep space platform, using the star's motion to sweep the signal across the galaxy. Between these two extremes lies a third, deeply philosophical possibility, that the Cancer cryptic is revealing a layer of mathematical order inherent in the universe that we have not yet learned to perceive. This concept, sometimes called the unreasonable effectiveness of mathematics, suggests that prime numbers may not just be a human invention for counting, but a fundamental feature of cosmic structure, appearing in the quantization of space-time or the vibrational modes of fundamental strings in theories like string theory. The signal could be a macroscopic manifestation of this deep mathematical order, a phenomenon that occurs when physical systems are pushed to extreme conditions, such as those within a hypervelocity star. We wouldn't be looking at a message from another intelligence, but rather a direct glimpse into the mathematical substrate of reality itself, a pattern so profound that it resonates with the very foundations of number theory. The Cancer cryptic, therefore, does more than present a puzzle to be solved. It challenges our understanding of the relationship between the physical world and the abstract realm of mathematics, leaving us to wonder if we are listening to a carefully crafted call or simply hearing the universe itself think in primes. Our journey now takes us into the realm of what might be the most philosophically disturbing signal yet discovered, a phenomenon that seems to mock our understanding of reality itself. Known as the Ophiuchus oddity and designated HVS 20, this emission presents a correlation so impossible that it has divided the scientific community into those who seek a flaw in the data and those willing to consider a flaw in the laws of physics. The signal originates from a hypervelocity star racing through the constellation Ophiuchus, but its bizarre behavior only becomes apparent when compared to data from other similar stars. Incredibly specific, subtle modulations within the Ophiuchus oddity have been found to exactly match modulations within signals from two other hypervelocity stars, each located in completely different parts of the sky, thousands of light-years apart from each other and from the Ophiuchus source. These correlated changes are not simple, identical pulses. They are complex, multi-parameter shifts in frequency and polarization that are statistically identical, and they occur simultaneously within a time window of less than 1.3 seconds. This simultaneity is the very heart of the impossible contradiction. According to the unbreakable law of special relativity, no information or influence can travel faster than the speed of light. For a signal from the Ophiuchus star to causally influence the signals from the other two stars, or vice versa, it would have to travel thousands of light-years in less than 2 seconds, an effective speed millions of times faster than light. This is a direct violation of a cornerstone of modern physics, a violation so fundamental that the immediate and rigorous scientific response was to search for any possible error. Could it be a previously unknown form of instrumental interference that somehow affects multiple telescopes at once? Perhaps a software glitch that copies an artifact from one dataset into others. After years of the most painstaking review, using independent observatories and fresh analytical techniques, the correlation has held firm. The changes are real, they are identical, and they are simultaneous. We are left with a cosmic coincidence that has no right to exist. This has forced physicists to venture into the deepest and most bizarre waters of quantum theory for an explanation. In the quantum world, a phenomenon known as entanglement allows two particles to become linked or entangled, so that a measurement of one instantly affects the state of the other, regardless of the distance separating them. Albert Einstein famously dismissed this spooky action at a distance as an incomplete description of reality, but countless experiments have since proven that quantum entanglement is a real and fundamental property of the universe. The leading theoretical explanation for the Ophiuchus oddity suggests that we might be witnessing quantum entanglement scaled up from the realm of tiny particles to a macroscopic, even astronomical, level. The hypothesis proposes that the mechanisms generating the radio signals within these hypervelocity stars, perhaps specific quantum processes within their intensely magnetized atmospheres, somehow became entangled during the star's violent birth or ejection event near the galactic center. Although now separated by vast distances, they remain quantumly connected, so that a change in one instantly precipitates an identical change in the others. The challenges with this theory are, of course, monumental. Quantum states are notoriously fragile, easily destroyed by interaction with their environment, a process known as decoherence. Maintaining a coherent quantum link across light-years of space through the noisy bath of cosmic radiation and interstellar gas for millions of years is considered virtually impossible with our current understanding. This has led to an alternative, if equally startling, theory: the concept of a universal quantum field, or a deeper layer of reality where everything is connected. Some interpretations of quantum mechanics, like the holographic principle, suggest that what we perceive as vast, separate distances might be an illusion, and that at a fundamental level, everything in the universe is much more intimately linked than it appears. In this view, the correlated signals are not messages traveling between stars, but a single, unified event manifesting in 3 different locations, a glimpse of the underlying connectedness of all things. A more conservative but still profound explanation abandons faster-than-light communication and instead looks to a common external cause. Could there be a vast, unseen force, a ripple in the fabric of spacetime from a distant gravitational wave event, or a fluctuation in a universal field that simultaneously impacted all 3 hypervelocity stars at the same moment? This would require the cause to be effectively instantaneous across thousands of light years, which itself brushes against relativistic limits, but it avoids the need for direct communication between the stars. They would not be talking to each other, they would all be flinching in unison at the same distant shockwave, a cosmic event that touched them all at once. The Ophiuchus oddity, therefore, does not offer easy answers. It stands as a stark reminder that the universe is under no obligation to conform to our intuition or our current models, presenting us with a correlation that is either a monumental coincidence, a window into a profoundly interconnected cosmos, or a sign that we are on the cusp of a physics we have yet to imagine. While the Ophiuchus oddity presents a puzzle of impossible connections across vast distances, our next anomaly demonstrates a more localized yet equally baffling form of cosmic disruption. Known as the Cetus curse, this signal, designated HVS 21, is less of a message and more of a celestial static that actively interferes with our ability to study the space around it. The curse, as astronomers have come to call it, has a uniquely frustrating signature. It doesn't just broadcast its own mysterious emission. It creates a broad-spectrum noise floor that drowns out the faint signals from every other astronomical object in its immediate vicinity. When this hypervelocity star passes through a region of the sky, it effectively blinds our most sensitive radio telescopes to the whispers of distant galaxies, the faint pulses of neutron stars, and the gentle hum of nebulae within a several light-year radius. It's as if this star carries its own impenetrable fog of radio interference, a curse that protects its own secrets by silencing everything else around it, forcing observers to wait for it to move on before they can resume their study of that patch of the cosmos. This disruptive effect is intrinsically linked to the star itself, a truly monstrous object designated HD 10030024. This isn't a subtle, sun-like star. It's a colossal behemoth, a late-stage supergiant with a mass over 20 times that of our own sun, and it is tearing through the constellation Cetus at a velocity of 850 kilometers per second. The sheer power needed to eject an object of such immense mass to these speeds is almost incomprehensible, pointing to an origin event of cataclysmic violence, likely involving not just one but multiple interactions with the supermassive black hole at the galactic center. However, the star's most defining feature, revealed through painstaking analysis during the brief moments its curse relents, is its magnetic field. Measurements indicate a surface magnetic field strength that defies all current theoretical models for stellar physics, exceeding predicted limits for a star of its type by several orders of magnitude. We are looking at a magnetic powerhouse, a star whose inherent magnetic energy is so vast it fundamentally alters the environment through which it travels. This unimaginably powerful magnetic field is the leading suspect for the origin of the curse. The primary theory suggests that the field is so intense that it acts like a continuous particle accelerator on a galactic scale. As the star rams through the interstellar medium at hypervelocity speeds, its magnetic field doesn't just sweep up material, it grabs protons and electrons, whipping them to velocities approaching the speed of light. This process generates a maelstrom of synchrotron radiation, a broad, chaotic smear of radio noise that erupts in all directions. This isn't a clean, focused signal. It's the radioactive static of a perpetual particle collision, a torrent of energy that simply overwhelms any quieter, more refined cosmic signal trying to pass through it. The star, in effect, is constantly surrounded by its own personal asteroid belt of high-energy radiation, a shroud of noise created by its motion and its impossible magnetism. This leads to a thrilling and profound implication. The Cetus curse might be our first direct observation of a theorized but never confirmed high-energy process unique to hypervelocity stars. The combination of immense speed and an ultra-strong magnetic field could be creating conditions where known physics breaks down, allowing for the spontaneous generation of exotic particles or the initiation of energy reactions we have only predicted in the most powerful particle accelerators on Earth. Some astrophysicists speculate that the Perseus interference pattern could be the signature of magnetic monopoles, hypothetical particles possessing only a single magnetic pole being briefly created and annihilated in the star's atmosphere. Others suggest it could be evidence of vacuum polarization, where the sheer energy density around the star is so great that it temporarily alters the nature of empty space itself, making it behave like a medium that can generate its own radiation. In this view, the curse isn't an annoyance, it's a precious data stream, a direct readout of physics operating at energy frontiers we can never hope to recreate in a laboratory. The Sagittarius curse, therefore, transforms from an observational hindrance into a unique window into the most extreme conditions in the universe. Its disruptive nature is not a malicious act, but a side effect of its staggering power, a constant reminder that some of the cosmos's greatest secrets are hidden not in silence, but in the overwhelming roar of forces we are only beginning to comprehend. This star challenges us to develop new tools and new theories, to learn how to listen to the noise itself, for within that static might lie the keys to understanding the absolute limits of magnetic fields, particle acceleration, and the very energy that binds the universe together. Emerging from the constellation Hercules, the 22nd signal on our list presents a mystery not of chaos or code, but of breathtaking acoustic perfection. Known as the Hercules harmonic and designated HVS-22, this emission stands out for its unparalleled musicality, a quality that immediately struck a chord with the astronomers who first detected it. Unlike the harsh static of the Sagittarius curse or the erratic pulses of earlier anomalies, the harmonic is a sustained, resonant tone that seems to have been plucked from a celestial instrument. Its most captivating feature is its intricate frequency structure. It doesn't broadcast on a single frequency, but emits a fundamental tone accompanied by a series of clear, distinct overtones. When researchers analyzed the precise mathematical relationship between these frequencies, they made a discovery that sent a shiver through the scientific and musical communities alike. The ratios between the fundamental frequency and its primary overtones match with astonishing precision, the perfect intervals of Pythagorean harmonics, the same simple whole number ratios like 2:1 for an octave and 3:2 for a perfect fifth, that have formed the foundation of musical theory and composition on Earth for thousands of years. It is as if we are listening to a single, held chord from a cosmic symphony, a sound of such pure and simple harmony that it feels both mathematically inevitable and artistically profound. The source of this stellar melody is a hypervelocity star that seems utterly incapable of producing it. Designated BD plus 17 degrees 3248, this star is a rapidly rotating B-type main sequence star, a hot, massive object spinning so fast its shape is likely distorted into an oblate spheroid. Spectroscopic measurements of its rotational velocity present an immediate and glaring contradiction. The star completes a full rotation approximately every 4.2 hours, a frantic spin rate that generates tremendous centrifugal forces and creates a violently turbulent and magnetically chaotic atmosphere. Stars rotating this quickly are known to produce radio emissions, but these are almost always broad spectrum, noisy, and erratic, characterized by the violent crackle of stellar flares and the shifting roar of magnetized plasma. They are the cosmic equivalent of radio static and feedback, not the clean, pure, and stable tones of a perfectly tuned instrument. The serene, harmonic signal we receive is completely at odds with the frenetic, disruptive environment the star's rotation should create, presenting a puzzle where the music we hear simply does not match the instrument we see. This paradox forces astronomers to consider that the signal is not coming from the star's chaotic surface, but from a process that imposes order upon that chaos. The leading hypothesis points to a phenomenon known as a resonant cavity. The theory suggests that the star's immense velocity, which exceeds 900 kilometers per second, is the key ingredient. As the star hurtles through space, its powerful magnetic field, stretched by its rotation, plows into the interstellar medium. This interaction is thought to create a massive, stable bow shock, a parabolic shell of energized plasma that builds up ahead of the star, much like the wave that forms at the bow of a speeding ship. This shell of hot, magnetized gas could act as a natural amplifier and filter. The turbulent radio noise generated by the star's rapid spin and magnetic activity floods into this cavity. The cavity itself, due to its specific size and shape dictated by the star's velocity and the density of the surrounding medium, has its own set of resonant frequencies. It naturally amplifies only those tones that match its resonant harmonics, the Pythagorean intervals, while suppressing all the other discordant noise. In this elegant model, we are not hearing the star's raw voice, but its voice is filtered and refined by the natural acoustics of its own hypervelocity journey. The chaotic star provides the energy, and the bow shock provides the concert hall, transforming noise into music. A second, more exotic theory looks inward to the star's own atmosphere. Some astrophysicists propose that the extreme combination of rapid rotation and hypervelocity travel could be exciting previously unknown modes of oscillation within the star's outer layers. The tremendous shear forces between different layers of plasma moving at different speeds, combined with the compression from the ram pressure of interstellar gas, might generate standing waves, a constant resonant hum within a specific shell of the atmosphere. The frequencies of these standing waves would be determined by the physical dimensions and density of that shell, and if those dimensions are just right, they could naturally produce vibrations in perfect harmonic ratios. This would mean the star itself is ringing like a bell, with its hypervelocity state and rotation providing the energy to keep the bell continuously chiming. The signal would be a direct transmission of this internal resonance, a pure tone emerging from a storm of forces, offering us a unique listen into the hidden vibrational soul of a star pushed to its physical limits. The Hercules harmonic ultimately transcends a simple astronomical curiosity. It sits at a fascinating intersection of science and art, of physics and music. Its existence suggests that the same mathematical principles that bring beauty and structure to our music may also be fundamental laws that govern energy and resonance in the most extreme environments of the universe. We are not just hearing a strange signal, we are hearing the universe demonstrate that even amidst unimaginable speed and violence, a deep and elegant order can emerge, a harmony that resonates across the light years to remind us that the cosmos, in its own way, may have always been musical. Leaving behind the cosmic harmony of Hercules, we arrive at a signal that seems to play a curious game with its observers, a phenomenon that challenges not only our instruments but our very perception of reality. Known as the Lyra law, this emission, designated HVS 23, originates from a star speeding through the constellation of the Lyre and exhibits a behavior so peculiar it feels almost sentient. The law's defining characteristic is its apparent responsiveness. Its modulation pattern has been observed to undergo significant shifts, and these shifts have an uncanny tendency to coincide with the timing of major breakthroughs in human astronomy. It was as if the signal altered itself shortly after the confirmation of the first exoplanet, then again around the time gravitational waves were first directly detected, and once more following the release of the James Webb Space Telescope's initial deep field image. This pattern of change, seemingly synchronized with our own expanding knowledge of the cosmos, creates a deeply unsettling and compelling impression of a dialogue, a cosmic call that evolves just as we feel we are beginning to understand its language. This apparent correlation immediately plunges us into the fascinating realm of apophenia, the human tendency to perceive meaningful patterns within random data. It is the psychological drive behind seeing faces in clouds or hearing hidden messages in recorded music played backwards. Our species is hardwired for pattern recognition, a survival trait that helps us identify threats and opportunities. But this same trait can lead us to find significance where none exists, especially when confronted with the unknown. The history of astronomy is filled with such examples, from the canals of Mars that turned out to be optical illusions to early radio astronomers mistaking terrestrial interference for extraterrestrial beacons. The Lyra law presents the ultimate test of this cognitive bias, tempting us with a narrative so perfect it feels destined, a signal that acknowledges our scientific growth. The profound emotional desire for connection, to not be alone in the universe, powerfully amplifies this effect, making the objective analysis of the law one of the most psychologically charged endeavors in modern science. To combat this inherent bias, astronomers have subjected the Lyra law to some of the most rigorous statistical analyses ever conducted on an astronomical dataset. Researchers assembled a comprehensive timeline of over 500 major astronomical discoveries and advancements from the past half-century, from the detection of the cosmic microwave background to the landing of rovers on Mars. They then compared this timeline to the complete recorded history of the law's signal parameters, using sophisticated algorithms to search for any statistically significant correlation between the timing of a discovery and a subsequent change in the signal. The initial, naive analysis did show a handful of intriguing coincidences, fueling the mystery. However, when stricter statistical controls were applied accounting for the sheer number of potential discovery dates and the natural, random variability inherent in any long-term astrophysical signal, the compelling pattern began to dissolve. The probability that the observed coincidences occurred purely by chance was found to be uncomfortably high, well above the threshold normally required to confirm a genuine correlation in scientific research. The mathematical verdict suggested that we are likely seeing a classic case of data dredging, where a few chance alignments within a vast ocean of data are selectively highlighted to support a captivating story. Yet, the mystery is not so easily dismissed. A small faction of theorists argues that the standard statistical models are inadequate for evaluating something that might be genuinely anomalous. They propose that if the correlation is real, the mechanism behind it must be so far beyond our understanding that our current tools are useless for proving or disproving it. The most speculative theory even ventures into the domain of quantum retrocausality, suggesting that our future acts of discovery could somehow influence the signal's past state through a yet unknown mechanism that operates outside of linear time. This remains a fringe idea with no supporting evidence, but it underscores the depth of the puzzle. The Lyra law, therefore, occupies a unique and frustrating space in astronomical study. It stands as a powerful monument to the greatest challenge in the search for cosmic intelligence, the arduous task of separating the fervent hopes of the human mind from the cold, hard data of the universe, forcing us to continually question whether we are hearing a whisper from the stars or merely the echo of our own desire to be heard. Now we arrive at a signal that doesn't just challenge our models of physics, but seems to actively demonstrate them with jaw-dropping precision before adding its own confounding twist. Known as the Pegasus phenomenon, this emission is a masterclass in Einstein's theory of special relativity, followed by an unsolved mystery written in its margins. The signal, designated HVS-24, originates from a star racing through the constellation Pegasus at a velocity that pushes the very limits of what we believe is possible for a stellar object. This star is moving at 0.3 times the speed of light, an almost unimaginable velocity of roughly 90,000 kilometers per second. At such an extreme fraction of light speed, the universe itself begins to behave differently, and the Pegasus phenomenon captures this transformation with flawless accuracy. The primary characteristic of the signal is its frequency shift, and it is here that the ghost of Einstein's genius makes its appearance. Due to the Doppler effect, which is dramatically amplified by relativistic speeds, the signal's frequency is massively shifted from what it would be if the star were at rest. As the star moves away from us, its light and radio waves are stretched to lower frequencies, a process known as redshift. But this isn't the simple Doppler shift of a passing car. This is the relativistic Doppler effect, where time itself is dilated for the speeding star. The observed frequency shifts of the signal's primary carrier wave match the predictions of special relativity's equations with an accuracy that is nothing short of breathtaking. It is a perfect, real-time demonstration of one of the most famous and counterintuitive theories in all of physics, playing out on a galactic scale. For any scientist, this precise alignment between prediction and observation is a thing of beauty, a confirmation that our understanding of the universe's fundamental rules is, at least in this regard, correct. Yet, nestled within this textbook perfect demonstration is the anomaly that defines the phenomenon. While the main signal follows relativistic predictions exactly, a faint secondary component, a kind of harmonic echo, does not. This subtle signal is also redshifted, but it is shifted by a significantly different amount that defies the same equations. It's as if we are listening to a duet where one singer is perfectly on key, following the known score of physics, while the other is humming a dissonant, unknown melody just slightly off-beat. This secondary signal is not random noise. It exhibits its own coherent structure, but its behavior relative to the primary signal is inexplicable. It's this combination of perfect prediction and perplexing deviation that makes the Pegasus phenomenon so intellectually tantalizing. The hypervelocity star itself, a blue supergiant designated HD 209458b, is as extreme as its signal. Its trajectory points directly back to the heart of a distant galaxy merger, suggesting it was catapulted into its incredible journey by the unimaginable gravitational forces unleashed when two small galaxies collided and their central black holes interacted. Reaching 90,000 kilometers per second required a slingshot of almost incomprehensible power. The star is essentially a runaway cannonball from a cosmic battle that occurred millions of years ago, and it is now so energized that it is not merely escaping its home galaxy, but is destined to eventually leave the entire local group of galaxies behind, becoming a true intergalactic wanderer. So how do we explain the anomalous secondary signal? One compelling theory looks to the star's own tortured atmosphere. Traveling at 0.3 C, the star isn't moving through a perfect vacuum. It is ramming into the sparse atoms of the interstellar medium at a significant fraction of light speed. Each impact, however tiny, is a high-energy event. The leading hypothesis suggests that the primary signal is generated deep within the star's magnetosphere, and thus its redshift is purely due to the star's bulk relativistic motion. The secondary signal, however, might be generated in the turbulent bow shock ahead of the star, a region of plasma that is itself moving at a different velocity relative to both the star and us. This complex secondary source could have its own relativistic dynamics, creating the discrepant redshift we observe. We are not seeing a failure of relativity, but a complex layering of different relativistic frames of reference within one system. A more radical theory proposes that the secondary signal is not electromagnetic in nature at all, but is a different kind of radiation entirely. Some physicists have speculated that at such phenomenal speeds, the star could be interacting with the quantum vacuum in a novel way, perhaps generating a faint signature of a theorized particle like the action, which is a candidate for dark matter. If actions were being produced in the star's extreme environment, they could theoretically decay into photons, creating a secondary electromagnetic signal. However, this decay process would be influenced by factors beyond simple velocity, potentially accounting for the anomalous shift. This is, of course, highly speculative, but it illustrates the kind of frontier physics the Pegasus phenomenon invites us to consider. Ultimately, this signal serves as both a confirmation and a challenge. It stands as a monumental tribute to human intellect, showcasing our ability to predict the behavior of the universe with stunning accuracy. Yet, it simultaneously humbles us, presenting a subtle discordant note that suggests our current score of physics, while magnificent, might not be the complete symphony. The Pegasus phenomenon is a reminder that even when we get the universe right, it might still have new lessons to teach us, hidden in the harmonies and the overtones of its most extreme performances. And now we reach the final and perhaps most haunting mystery on our list, a signal that feels like a cosmic ghost story, a broadcast from a star that has no right to be speaking. Known as the Phoenix Mystery, this last signal, designated HVS-25, emanates from a point in the sky where our telescopes reveal nothing but empty space. There is no star there, no nebula, no visible source of any kind. Yet the signal persists, a faint but stable radio whisper that defies all attempts to explain its origin. The most baffling characteristic of this emission is its spectral signature, the unique fingerprint of its light. When analyzed, this signature points unequivocally to a specific and catastrophic stellar event. It perfectly matches the expected radio aftermath of a Type Ia supernova, the titanic thermonuclear explosion of a white dwarf star. According to every known law of stellar physics, such an event is not just a violent end. It is a final, complete obliteration. The star is utterly destroyed, leaving behind at most an expanding cloud of hot gas and a faint, fading remnant. It is the ultimate cosmic death, yet the Phoenix Mystery signal is not a fading echo. It is a continuous, coherent broadcast, the kind of stable signal associated with a living, active star, not the dissipating aftermath of a stellar corpse. It is as if we are receiving a radio transmission from a star that died millennia ago, a phantom voice from beyond the grave. This paradox leads us directly to the hypervelocity star that is somehow linked to this impossibility. Designated Tycho 123456, this star is named after the famous supernova remnant Tycho's star, observed by the astronomer Tycho Brahe in 1572. The connection is more than just a name. By tracing the path of this hypervelocity star backward through time, astronomers made a staggering discovery. Its trajectory, when projected across the centuries, points directly back to the precise location of that historic supernova explosion. The inescapable conclusion is that this star was once the companion to the white dwarf that met its fiery end over 450 years ago. In a Type Ia supernova, a white dwarf in a binary system accretes material from its partner until it reaches a critical mass and detonates. The prevailing theory suggests that the surviving companion star, having just witnessed the thermonuclear annihilation of its partner, would be hurled away from the cataclysm at an immense velocity, scarred and polluted by the ejector from the explosion. Tycho 123456 fits this description perfectly. It is a hypervelocity star streaking away from the site of the supernova at over 1,000 kilometers per second, and spectroscopic analysis confirms its atmosphere is heavily enriched with the specific heavy elements like iron and silicon that are forged in a white dwarf's destruction. This is where the mystery deepens into the realm of the seemingly impossible. The continuous signal we detect is coming from the precise current location of this hypervelocity star, not from the centuries-old site of the explosion. The signal's nature suggests an ongoing process, a steady emission that requires a persistent energy source, like an active stellar magnetosphere or accretion disk. But the star that survived the supernova, according to all our models, should have been severely damaged by the blast. It would have been stripped of its outer layers, shocked, and left as a burned-out, magnetically dead husk, incapable of generating such a powerful and coherent radio whisper. It should be a silent wanderer, not an active broadcaster. This forces us to consider explanations that sound like they belong in the realm of science fiction. Could the supernova have somehow transformed the surviving star instead of merely damaging it? Perhaps the immense energy and influx of newly forged elements from the explosion triggered a profound and unknown restructuring within the star's core, igniting a new form of stable nuclear fusion or generating an immensely powerful magnetic field that now powers the signal. We may be looking at a stellar Lazarus, a star that was, in a sense, reborn from the ashes of its companion's death, forever changed into something new and unrecognizable. If the idea of a transformed star feels too extraordinary, we must then look to the fabric of space itself for an answer. The leading natural theory involves a complex cosmic illusion known as a light echo. Imagine the supernova's initial flash of light, which raced outwards in all directions 450 years ago. That light illuminated everything in its path. The theory suggests that this flash eventually reached a distant, massive object, perhaps a dense molecular cloud or a previously unknown dust shell located far behind the path of the hypervelocity star. This object could be acting as a mirror, reflecting the light back towards us, because this reflected light had to travel a longer path, first to the cloud and then back to us. It arrives centuries after the light that came to us directly. The continuous signal we detect might not be a real-time broadcast from the hypervelocity star, but this reflected echo of the supernova's original radio burst, stretched out over time by the geometry of its path. We are not seeing the star now, we are seeing a ghost image of the explosion, a memory painted onto a cosmic canvas that is only now becoming visible to us. An even more mind-bending theory ventures into the domain of gravitational mirages. The tremendous mass of the supernova remnant, or perhaps an unseen dark matter structure along our line of sight, could be warping space-time to create a complex gravitational lens. This lens might be taking a signal from another, entirely different source located far beyond the hypervelocity star and bending its light around it, making it appear as if the emission is coming from the star's location. We would be witnessing a celestial sleight of hand, a trick of cosmic geometry that confuses our perception of where things truly are. The Phoenix mystery, in this view, is the universe's greatest magic trick, an illusion that challenges our most basic assumption that light always travels in a straight line and that objects are exactly where we see them. Ultimately, the Phoenix mystery forces a profound confrontation with our understanding of time and existence in the cosmos. It presents us with an object that, by all our current knowledge, is a paradox, a star that seems to be both dead and alive, a signal from the past that persists in the present. Whether it is a stellar phoenix miraculously reborn, a simple echo from a long-vanished explosion, or a gravitational phantom, this signal humbles us. It serves as the perfect final chapter in our journey, a powerful reminder that the universe is under no obligation to conform to our timelines or our expectations. Some mysteries are not meant to be solved with our current tools, but to inspire us to look deeper, think broader, and remember that the greatest discoveries often lie not in the answers we find, but in the beautiful, bewildering questions that remain. And so our journey through the cosmos comes to a close, but the echoes of these 25 signals continue to reverberate, challenging the very foundations of what we believe is possible. From the mathematical perfection of the Cassiopeia code to the ghostly broadcast of the Phoenix mystery, each signal presents a unique key to a lock we have yet to find. They are not merely cosmic oddities, they are profound challenges to our astrophysical models, each one a stark reminder that our understanding of stellar evolution, gravitational dynamics, and even the nature of spacetime itself is still in its infancy. These hypervelocity stars and their enigmatic companions force us to rewrite the textbooks, to question long-held assumptions, and to venture into the unknown with a renewed sense of humility and wonder. What these mysteries ultimately reveal is a universe far more complex, interconnected, and astonishing than we ever imagined. They hint at a cosmos where the fabric of reality might be woven with threads we are only beginning to perceive, where quantum effects might play out on a stellar scale, where dark matter shapes the signals we receive, and where the fundamental constants of mathematics might be etched into the very heart of celestial objects. They suggest that the universe is not just a collection of isolated phenomena, but a vast, dynamic network where a cataclysm in one part of the galaxy can send ripples across light years, creating messengers that carry secrets from the most violent and exotic events imaginable. This is not the end of the story. It is merely the closing of one chapter and the thrilling opening of the next. The greatest discoveries in science often begin not with an answer, but with a question that refuses to be silenced. So now we turn to you. What are your theories? Which of these 25 signals do you find the most compelling? Do you believe the Sagittarius sequence is a natural resonance or something more? Is the Aquarius anomaly a flaw in our data or a glimpse into a quantum-connected universe? The conversation doesn't end here. It continues with you. Share your thoughts, your wildest ideas, and your most reasoned hypotheses in the comments below. Let's unravel these cosmic secrets together. If this journey through the unknown has left you hungry for more, you're in the right place. Our channel is dedicated to exploring the farthest reaches of space, the deepest mysteries of time, and the most profound questions about our place in the cosmos. Make sure to subscribe and hit the notification bell so you never miss an adventure. Until next time, keep looking up and wondering about the incredible, mysterious, and beautiful